Hello, good morning students. Already we have finished the transmitter power. Okay, how to calculate the transmitted power. Today we will take problems based on the modulation index. Okay, a modulating signal. Today we will take one problem based on calculation of modulation index. Calculation of percentage modulation index, sideband frequency and their amplitudes. Okay, so today we take one example. A modulating signal, a modulating signal 20 sine of 2 pi into 10 raised to 3t. Okay, this is my modulating signal. Is used to modulate a carrier signal 40 into sine of 2 pi into 10 raised to 4t. Okay, so this is given and we have to find out. First modulation index, second percentage modulation index, third sideband frequencies and their amplitudes, sideband frequencies and their amplitudes, and last one, bandwidth of AM wave. Fourth one, that is bandwidth of AM wave. Okay, so we have given the modulating signal and carrier signal. Okay, so first we will write what is given, that is what is first modulating signal. Modulating signal is given by equation, that is a EM, small em is equal to capital EM into sine of 2 pi fmt. This is the standard equation and it is equal to 20 sine of 2 pi into 10 raised to 3t. Okay. Then next what is given? That is carrier signal. So EC is equal to standard equation of carrier signal, that is capital EC into sine of 2 pi into fc into t, that is equal to 40 sine of 2 pi into 10 raised to 4t. Okay, so comparing this given equation with standard equation, we get the value of EM. EM is equal to, what is the value of EM? If we compare this equation with this standard equation, this is the standard equation. This is given. Okay, so EM is equal to 20 volt. Then FM is equal to 10 raised to 3. Then EC is equal to 40 volt. and last one, that is a FC. FC is equal to 10 raised to 4 hertz. Okay. Then we have to find first modulation index. What is the formula for modulation index? That is M is equal to modulation index. M is equal to, that is EM by EC. Okay. So that is equal to, what is the value of EM? EM is equal to 20 volt. EC is equal to 40 volt. Okay, so that is equal to 20 divided by 40. That is equal to 0.5. Okay, so this is my first modulation index of AM wave. Then we will calculate percentage modulation. Percentage modulation is given by equation, that is M is equal to percentage M is equal to EM by EC into 100. We know M, that is equal to 0.5 into 100, that is equal to 50%. That is the percentage modulation index is equal to 50. Clear? Then we have to find out the sideband frequencies. We have to find out the sideband frequencies. What is the sideband frequencies? That is a LSB and USB. Okay. Lower sideband frequency LSB is equal to FC minus FM, and upper sideband frequency FLSB is equal to FC minus FM, and FUSB is equal to FC plus FM. We know FC, we know FM. Okay. So FLSB is equal to FC, that is a 10 raised to 4 minus 10 raised to 3, that is 1000, that is equal to 10,000 minus 1000, that is 9000 hertz, or we can write it as a 9 kilohertz. Okay. Similarly, FUSB is given by equation, that is FC plus FM, that is equal to 10,000 hertz plus 1000 hertz, that is equal to 11,000 hertz, or you can write 11 kilohertz. Okay, so this is about FLSB, lower sideband frequency, that is 9 kilohertz, and FUSB, that is 11 kilohertz. Yes, any doubts? Out of these 4, we have calculated the 3. First one, modulation index, percentage modulation index, lower sideband frequency, upper sideband frequency. Okay. Then we will calculate their corresponding amplitudes. Their corresponding amplitude. We know that their corresponding amplitudes for FLSB and FUSB that are equal. So I will write here FUSB, or we can write the USB amplitude. USB amplitude is equal to LSB amplitude. LSB amplitude. But what is the formula To find out the amplitude, we know that amplitude of sidebands is given by equation that is m into AC by 2. We know the value of m, we know the value of EC, then we can calculate that is m is equal to 0.5 into EC that is equal to 40 divided by 2. Okay, 2 1s are 2, 2 2s are 4, 0. Then this will be 10 volt amplitude. Amplitude of sideband that is equal to 10 volt. Okay, yes, any doubts? Next, what is the remaining? I will erase this. Last point, that is the bandwidth of AM wave. Bandwidth of AM wave. What is the bandwidth of AM wave? Bandwidth of AM wave. Bandwidth of AM wave is given by equation that is FUSB minus FLSB. Okay, we know that FUSB that is equal to 11 kilohertz minus 9 kilohertz that is equal to 2 kilohertz. This will be the bandwidth of AM wave. If question is asked, draw the frequency spectrum of AM wave, then we can draw frequency spectrum very easily. I will draw here frequency spectrum. I will erase this problem. We know that AM has only two sidebands. This is the FC. What is the amplitude of FC? Amplitude of FC is given that is a 40 volt. Okay. Then upper sideband frequency that is FUSB. FUSB, what is the value of FUSB? That is 11 kilohertz. So, and its amplitude is 10 volt. Similarly, FLSB, its amplitude is again 10 volt. 10 volt. This is FLSB. Okay. So, this is about calculation of modulation index, percentage modulation index, bandwidth of AM wave, upper sideband frequency, lower sideband frequency, and frequency spectrum. Frequency spectrum of AM wave. On x-axis that is frequency, y-axis that is the amplitude. FC carrier frequency having amplitude 40 volt, and sideband frequency that is FLSB and FUSB, amplitude of both FUSB and FLSB is equal, that is 10 volt.